The old man will. The old man will. The old man will. The old man builds. The old man builds is broken in the head. People not seeing reality has put them in the red. Where conscious and spirituality restricted from the norm and replaced with the ignorance of basic magnetic form. The geometry of God keeps running through his head. That's what makes old man builds broken in the head. The old man builds. The old man builds. Spheres of destiny are spinning in his mind, making him travel back and forth in time, battling the establishment for just a little recognition. Has him forcing the world to understand his premonition. That world will have all the technology in the end, even if it means his life will fail to instead. The old man builds. The old man builds. The old man builds. The old man builds.
Hello everyone and welcome. Today is just another fun day, guys. What's up? I see everybody's in the house today. Right on, man. Guys, we're doing something a little different today. We're changing things up. Basically what's going on is we're going to discontinue the Fringe Think Tank for a while. We'll all keep in touch as individuals, but I'm going to podcast alone from here on out. I'll keep the Wednesdays with Sean and the Saturdays with Joe. Basically, just differences in opinions and scheduling is causing some of this stuff. We all know Gerald's kind of doing his own thing right now and working on his family and stuff. And I have a feeling he wanted to just kind of pop in and out, and that's cool. And Ben's kind of doing his own thing and going down a road with some political stuff on his channel that I don't agree with. So we just kind of separated ways there. And he also needs some more shifts for his work for his family. So that's also cool too. So yeah, we're just going to keep it like this, man. Just you guys and me, and we're going to figure stuff out. You know, we're going to get into a topic usually every day. We're going to start doing Mondays, Wednesdays. I'm going to do a Friday show, all starting at 2 o'clock in the afternoon. And that should go about 2.5 hours, somewhere right around there, probably 2. And then Saturday, Joe and I will do our normal show. So that's what's going on from here on out, guys. We also have on Thursdays, we're going to start bringing in special guests. Now, today, I just want to show you some of their work and what we're looking forward to. We have some people lined up that we're going to talk to. So it's going to be really cool, guys. We had Mr. Lanius on this last Thursday. So without further ado, man, let's go ahead. I'm going to pull up their channels real quick so we can see this. One of the individuals I was talking to right here has to do with this experiment. I'll bring it up right now. I'm sure a lot of you know exactly what this is. It says Capes or something like that. I'm not a very good reader on this, but it's kind of like the one-wire energy that we were looking into. So this whole thing is pretty cool, man. So he's got this, and he hooks it to earth ground. He pulls energy out of the earth ground and everything. He does the lights like I do. It's built more like a Don Smith device than it is, a Tesla coil that I'm doing. So that's what I find very, very interesting about it. Let's go ahead and stop that one, and we're going to look. This is the individual right here, man. This guy's so cool. He's also got this. He does a Corona motor. And I find it absolutely fascinating how he gets it done. High voltage DC. So, yeah. This is pretty cool in itself, man. I could do a whole show on the Corona motor. But he got this thing, man. He got the purring like a kitten. So Let's show you some high voltage over there a little bit. As he gets this thing dialed in, makes energy out of it. It's really cool. So also, just so you guys know, he's just like one of us, man. Goes right into the woo. So that's going to be awesome as well. So I want to show you another inventor that I would also like to have on, and I've been talking with. Give me just a second to pull it up. Inventor 3. He does a lot of work on Tesla coils, man. And he sets them up and tests them. He's got this total framework that's done with no nails in it, just glue. So there's nothing getting in the way of understanding the resonance in the coils themselves. So let me pull off another one of his inventions that he did, man. Let's see where it is. He did this cool thing outside where he took a couple of Tesla coils, put them together with the rod down the center into the ground, and then he was pulling energy out of it. Sorry, it must be down here quite a ways. So what he's got going is those two Tesla coils are going with the rod right down to the center of the earth into the water table. And he's pulling energy from those Tesla coils right there. So being that we did the one wire energy, that's going to be absolutely outstanding to talk to him about that. And the fact that he does other inventions with the Tesla coil, looking for over unity in them. And I think that's going to work out really well. So there's a couple of them that we have going on, and give me a second. There's one other guy I'd like to talk to, and he does some of the coolest stuff, man. You just find his site on here. It's, well, I'll just tell you, it's negative rate coil with his bottles, the Tesla coil bottles. As soon as he's ready to do a live, man, I want to do it with him. Tesla coils that with bottles, when he puts all the crystal on the inside, man, and he gets that sucker humming and he gets extra energy out of it, that's awesome. So, yeah, I want to see that. So those are the three folks, man, that I'd like to have come in. I know we'll be talking to some people this weekend and then have next week's Thursday set up. I don't know who it's going to be this Thursday, but we'll see who's out there. But the next couple of weeks will be booked out for that. So that's pretty cool. Also, if you guys have something that you would like to have featured on the show, by all means, let me know. We could do pre-recorded, different time zones. I understand. So we can also do that. We can get into it and see what's going on. I think everybody's got some cool inventions out there. And I kind of really want to promote everybody, man, on what they're doing and showcase it. So, yeah, kind of a different format for me, guys. I didn't have a lot ready to go today as far as a presentation. I just kind of want to let everybody know the format and why we changed it. Look, I'm here every day. I do this show every single day. And all I want is for people to be here. And if I say they're going to be here when we send out the notices, I expect them to show up and be here on screen. So it's kind of irritating when you see in the comments, where's this person and why is that person and why are we streaming to their show if they're not here? Guys, I'm right there with you. I 100% understand. And I absolutely detest the question when it comes up because I know I wanted everybody to be here and I would like to know why they're not here. So, yeah, I kind of call me a strickler, but we got a show to put on, when we do this stuff. So everybody's got to be here and ready to go. So let's see. Yeah, negative res. Yes, absolutely. Yeah. Corona motor. Yeah, motor. Perfect. You guys are awesome, man. What is with the STLs you're sharing at the same time? The only problem I have with the STLs, guys, is some of the fit on it. Like, for instance, when the rod went down in it, and we could take a look at it real quick. When the rod went down in it, I wasn't 100% pleased with what I saw. So I'll bring that up right here. So if you take a look where it locks into the rod, it's like a 16th of a millimeter. That's millimeter, 16th of an inch. That's not tight enough on the side where they lock in. Now, by all means, the pins that you put in there probably stop that. But I just wanted to fill in that little bit of area in there so that when you get them, they're nice and tight. Because when that outer shell goes on, it's an interlocking outer shell. So, but it doesn't interfere with the screws that goes into them. So it should work out really well. I figured out all the rest of the geometries and everything else. This thing, guys, is off the chain. This is so cool. The only other thing I have to say is you see the two rods are not going in completely straight. So what I'm looking at is on the inside, I may have to throw another bearing and casing over the center ball that goes in there. It's a copper ball that goes in there. I may have to put it over just to make sure the rod's straighten out. I'm hoping those bearing holders on the outside cover that, but I'm not sure that they're exactly going to do that. So, yeah, that thing, man, it should be up and running here this week. I would have already had it done, guys. I busted my ankle. I busted my right shoulder. Somebody at the park had the dog loose and off the chain and startled me. And, well, I was a fat man rolling on the ground, and it took its toll on me. So I've been kind of limping around for the last couple of days. Anyway, we'll get through it, and then I'll have this thing built out. All I got to do is put the wooden frame together, turn on the motors. Everything else is set with the motor drivers, and I tested the motors already. They're all good to go. The power source on this is basically just a PC power source. So that's all I'm using for the main driving motors. And then my testicle, I use a normal power source that goes up to 40 volts. It goes up to 50 volts, but I generally don't go over 40. So we'll have plenty enough power to push out that radiant energy out of the center. So, yeah, we'll start it up, get it rotating. Once it's rotating and we know that all the machinery works, then it's time to take those little black cones that you see here, the little half circles. We're going to take those, and then we're going to decide, we want some foil tape or aluminum tape, however you want to say it, copper tape. We're going to start there, and then we're going to start adding different things. Can we get an electret in there? How do we build out the static field from that point? I'd love it to be an electret, but if I can't get that, what's the next best option? There's magnets in all of these. I can always take the inner side of it and put some kind of aluminum tape in there and hit it with a static field down the shaft of one of them, which static when it hits rotation will absolutely just go over the entire thing. So yeah, there's no problem doing that, getting static in there. I would like it a little more professional, but I'll take, what I can get in the beginning. The whole idea of this in the end is, we want to do what the UFOs do. So aluminum, bismuth, aluminum, trap the fields, confine them, let it go out the top and bottom. See, I'm not worried about that. I want them to go out the top and bottom because it's just like the earth. That's what we want to create. Some of this stuff may be good, man, just by putting dead zones in it on purpose or because maybe the electric's not sharp enough in that area. A lot of those things are miscellaneous fields that come out. This doesn't have to be perfect. Guys, if you're thinking I'm doing the Kozel device, just rethink that. I gave that out there for everybody to understand. We're kind of took the design and we're putting our own energy into it. I don't think he even knew what I was going to do or how I was going to build out the energy. They were probably thinking conventional energy. I'm sorry, it's just not going to work that way. So I'm going to build it out the way I think it should be done with the fields I think it should be done based on the, Gravity Flyers field that it makes. So once we do that, this thing's going to be special. This thing, like I said, the first iteration of it, check the mechanics. You can order parts based off the STL when you get them. And yeah, it'll be really cool, man. That was the only thing. I just wanted the thing to be right because some people just put it on their 3D printer and run it. Some people want to tweak the file. You know what I mean? Everybody's going to have a different view, but I'm going to try to put out the actual Fusion 360 file with it so that you can go in and edit the file directly so that it makes it easier for everybody. But again, I wanted to make sure that I had my file kind of cleaned up on what it was so that everybody could do that and kind of just work through it at your own pace. But for those who wanted it to print it out and go, I wanted to make sure that was right on. So, yeah, I love to say it's a simple build, guys. It's just some of it just takes time and a big, big headache to get through. So, yeah, it looks cool. But, yeah, we're going to have to do some crazy stuff with this thing. Like the movie Contact, yeah. A little bit different understanding on how the spheres rotate in dimension. But yeah, we could look at doing that down the road, man. That Contact movie was awesome, by the way. So yeah, we could look at doing something like that in the future. I don't know about dropping the ball down the center, man, because that honestly, that whole thing could be a complete disaster. You have PLA flying everywhere, big old ball flying at your head. If you drop it. Awesome, yeah. Yeah, not a simple build, man. Yeah, we all live in a yellow submarine. Some days it feels that way, man. I had somebody today ask me about mercury and putting it in a project. And, oh, yeah, you don't need that much of it. Well, you try ordering mercury in bulk. Let's see what shows up at your door and where you end up. Yeah, no, thank you. Never in my life am I working with that. That belongs in a proper lab, not in my garage. So yeah, imagine something kind of like this, but couldn't assemble it in my mind. Amazing. Well, right on, man. Yeah, hopefully this works out for everybody. Look, once it rotates, man, you have the SCL files. It's like open season on it, man. Just do what you want to do. The biggest time crunch it does on the big ones, if you put too much structure in it to make the 3D print that you have to tear out and throw away, then it takes you about 2 days to print it for each one of them. And that sucks. So I got to work on the support factor in there and cut it down a lot. And then we should be good to go on that one. So, but the rest of them weren't bad. A day. The smaller one took me about, I think, 6 hours, 7 hours. So, and then the second one took me a little over a day or right under a day, somewhere in there. And then the outside one took the longest. Now, I avoided running these things in super fast mode on my printer because I wanted the thickness in the inside to be filled too. So, yeah, it just took a little more time in this. But I have a program that'll cut it in half, but it also cuts out the structure on the inside a little bit. And I didn't want that. So just a difference in printing styles, I guess. The novel contact, huh? Was it different? I don't know. The rod, let me see. I got another one sitting right here. If I can grab it. Let's see. 5/16 by 0.014 or 7.94 millimeters by 355 millimeters. So kind of give you an idea of the rod size there. This one right here is just brass. I like the brass rods and how they interact with the radiant energy. It seems to work out good. I like the aluminum because it keeps things off of it when it's spinning and with the eddy current. So that's why I chose those two items in this. You see one side on the left side is the aluminum. The right side is brass. Now the hollowness has to do with the Tesla coil and how it interacts with that Tesla coil, because you don't want a solid rod in there. Solid rod's bad. It'll start absorbing the energy and it'll take forever to build up the field. But the hollow rod doesn't. It goes pretty fast. It goes right through it, gets right to the point of where you want it to go. So that's why I use that one. Sagan originally developed the idea on a screenplay in the late 1970s, but the film stalled. He turned it into a novel. Gotcha. Hollow brass, yeah. The same thing I use when I do my Tesla coil experiments. I put the rod down the center, hollow brass. I already know what's going to work. I know the reflectiveness is going to be seen on the thermal camera. So we're going to be able to see that fairly easy. So I've been trying to devise a way, guys, to be able to see this field. And I think I want to put some heat under it. And probably not the way that you're thinking. I want to take some sand and I want to heat the sand. And I want to see if I can't get the heat waves to come up and see if this field doesn't interact with it. I think it might. So we might be able to see something. We'll just have to change the camera and blur it a little bit. And we might be able to see the interaction of that field. So I'm hoping it does. God knows nobody else has found it yet, so we got to try something. Yeah, brass is nice, yeah. Surprisingly, a lot of things are made of brass when you get to stuff like this. And a lot of inventors like to use it. It's particularly because of the way it holds the fields. Let's see, when you gyro the interferometer, I don't know what that is. Good. Let's see, traces of gravity. That's interesting. Infrared interference. Yeah, that's what I'm hoping it is. So I want to say this. It's like if you build out a heat gas and this thing keeps the gas off of it, or I should say the heat off of it, it should show the heat signature on the outside of it. That's kind of the point, isn't it? If it'll show the heat wrapping around the ball or just on the sides of it even, we can identify where the field is. So yeah, a little bit of heat in there. You know what I mean? Just like the desert, as you see the waves of the desert coming up, that same effect is what I'm looking for. You like potatoes, huh? Well, I like potatoes too. Potatoes and mushrooms, yes. Little au jus sauce in there. That's usually good. A little bit of salt and pepper. A little bit of, what's that stuff? A little bit of garlic. Very, very, small little granules of garlic in there. Perfect, man. Nice potato that way. A little bit of green onion on there. A little light sprinkling of cheese, not overwhelming. Yeah, I'm there for that. You just had scalloped potatoes. Well, now I'm jealous. Snacking on tater tots. All right. I can live with that. Got it. I like that pedal. Yeah, if I'm not mistaken, Daniel Foster does a lot of musical stuff. So, I mean, if you ever had some interesting stuff you want to talk about music-wise, I'm sure he understands it. Yeah, garlic. Talking about lunch, man. Get me hungry over here. Let's see. Are you worried that the magnets might tear it? No. Energy destiny down to time delay. Why you have built this counter-rotating balls and not with disc, do you get the speed required? So, here's the thing. The radiant energy that comes out of this will be able to work at just about any speed. When I run the GraviFlyer, it's a flat disc, right? But I don't run it any more than 1,400 RPMs. So that's what, Alexi originally had in there, and that's what I run it at. I don't run it any faster than that. And I've gotten the fields to produce. So in this device, theoretically, we should be able to do the exact same thing. If we get the fields to produce, we should be able to do it in that RPM. Now, you could get your beat frequency for the whole craft to come down about 800 RPM, and you'll still build the field. So am I worried about the speed? No, not at all. I mean, if we had to, I could change out the motors, and that wouldn't be, much more than a couple-hour project. And I have other motors for that. I don't think it's necessary. And we're not trying to change the world here in one shot. We're just trying to make sure this thing doesn't fall apart on it when we hit the gas, if you know what I mean. Why would I do it instead of spheres, instead of flat plates? Well, it's 360-degree geometry. That's why. We're looking to create it exactly like everybody imagined Earth's fields to be. The sphere, and then coming out of the top and bottom, we're having energy being produced. So that right there is exactly what we're looking for. We want to build a magnetosphere out of this. I mean, in the very end, that's what we're looking for. That's the field we want. I mean, it's a gravity well. So, I mean, why not? And the only thing with rotation is I don't want it to fling it off right away. If I go to stick something on this, I want to make sure that it hits it and adheres to it. So we're going to have to go at very low speeds until we can build it up. It's not the rotational mass that I'm concerned with here. I want to make sure the fields build out as capacitors. You see, I think that's the trick. If they don't build out as capacitors and build up the energy as it flows to the outside, none of it's worth it. And I think that's what it is. We need the fields to build up layer by layer by layer and get stronger as they go out. Enough to make the outside field that projects in the air to be thicker and stronger. And I can't do that without that. So that's what I'm looking at. The GraviFlyer couldn't give me that. It couldn't compress the fields in one layer after another after another. 360-degree geometry is so much better than a flat plate in order to get that. Now, the best thing about that is when you go to stick it in some craft like a UFO, it builds it out in the correct geometry for the fields around the entire thing. Stick this sucker in the center, get what you want. So, yeah, that's kind of why I would be doing this. But the speeds thing, I think people put too much into it. I've seen these fields build out, and slower speeds are sometimes better in the beginning than faster speeds. And the faster speeds just make everything fall apart. Delay and phase shift. Yes. One of the bigger things we should be talking about is the directions of magnets per layer. Does it go, north, south, north? Or, the opposite, south, north, south? That's pretty interesting conversation. I don't know. Should they all go north? Should they all go south? I don't know that I could properly tell you that. I know I'm going to put them in there and tape the back. And, we'll just throw some duct tape on the back and see how it works out, because I'd like to be able to continuously switch them as I see fit on this first model until I get what I like. And then on the second model, we'll lock them in for sure. Oh, man. Yeah, that sounds good too. Guys, I'm on a diet right now, so it's every bit of food sounds good. The sound will blow my mind, huh? Is that on the pedal or the device? Oh, probably on the pedal. Let's see. If you think of magnetism as north-south as top-down, does the polarity of the static need to be across the Bosch wall null zone of the magnet? So, I want to say this. The null zone would be in the center of the magnet, and it's north and south on each flat side of it, if that's what you're asking. And then I don't know. See, here's the thing. We constantly see in the earth, when you get down to the ocean, it swirls this way and gets smaller down to the bottom. But what may surprise you is when you get to the actual atmosphere, it swirls big and gets smaller towards the outer part of the atmosphere. So could that be the magnetic field in there rotating in a spinning form just by the way it's created in the field up there somehow? And that's part of why it's interesting with the magnets. Which one do you want? You know what I mean? And which way? So we'll definitely have to figure that part out. Let's see. And Jarvis says alternate north, south, north. Yeah, it's kind of where I was thinking to start with. Sorry, get down here. Longitudinal and transverse, yes. And yes, we're getting both. That's the point here. We're getting both fields. That's the point. We want both. Everybody knows how these fields work by now. One's anti-gravity, but you got to create both in order to make them work together. So, yeah, exactly what we want. We're looking for time dilation, guys. That's what we're looking for. You cannot create gravity without time dilation. So, yep, that's 100% where we're going. I think a lot of people misunderstand this. Is it going to fly? No. You could break gravity sitting on the ground. It doesn't mean you're going anywhere. You don't have a propulsion system to go with it. I mean, breaking gravity and propulsion are two separate systems. You can take your device and move the energy charge in one direction on it, on something like this, once you get the outside fields, and yes, it'll move as your propulsion system. But first things first, we want to create the gravitational part of this. We need the time dilation part of it, which means this field is going to push out fairly quickly at low speeds. And I don't know how to say this to anybody who's never created it. It literally pushes that field quickly. 3 feet is nothing. Okay. 3 feet is 800 RPMs. So if you're standing next to this thing, you're getting a 3-foot field that you pick up very easily energy. But this type of energy isn't like your normal energy. So when it comes to 6 feet out, your meters will still pick up the field. You see, they go in spheres, just like rotating a magnet would. All of these fields build out like that, and they're layered, each one of them. So it doesn't just stop with the field where you can pick it up with the light bulb. It goes beyond that. And it'll go until it compresses your room. So we have to watch the time on each one of these things that we go with, because the amount of time may really screw up the whole thing. Because, how do I say this? If we wanted to create an outside field and like box this thing, I mean, that's what we would have to do, and create an outer box for it to stay in, so the fields can condense in this. And I'll be very honest with you, man. With something this size, 3 foot by 3 foot box, where we can actually pull a little bit of the air out of it, so that we can quicken the process of the fields being built. If we can get a little bit of that moisture to burn off in there quicker, then we're good to go, man. This thing will build up that field a lot faster. That's another thing with that dry area. It's not going to hurt us in building this field. Matter of fact, it might help. So, yeah, it's an interesting thing, man. So this looks like the Kozel device. Yes, it does look like the Kozel device. I said in the beginning, we took the design from the Kozel device, but we're going to run fields completely different out of it. But yes, absolutely. I wish my brain was bigger. God, I hope not for me, man. If it was any bigger, look at the size of my forehead. Do you really need that thing to be any bigger? They'd be calling me an alien after a while. Is it a reproduction? No. Like we just said, it's a same kind of blueprint, different things we're using all together. So, yeah, I don't want to build his device. I want to build my device, and I don't think he understood Tesla's radiant energy, and because of that, he missed out on a big opportunity with that device. And it has to do with some of the effects that they went based on the thing. And that's why I put that whole video out there that he talked about it. Some of those things will not apply here. Some of them will. And we're all going to have to just map them out. We'll put them on our board. We'll have 3 columns, in, out, and maybe right in the center. And we'll keep mapping it and seeing what happens. I mean, this whole thing's about the adventure of building and seeing how things goes. It's not about a predetermined outcome where you have a gravity flyer that somebody made lift and nobody else can. It's not, somebody else's device where they say 100% it's going to lift. No, this is, we took a design and we are changing everything based on the knowledge we have to put into it. That's what it is. So reproduction, no. And I think between the smart people that we have, with Jarvis, Sean, Joe, you know what I mean? Gerald when he's in it, and then also Ben when he's in it. Guys, some of these things are not really a problem. All the minds thinking on these kind of things really makes it easy. So, we also have new people coming in all the time. They have their devices, and we always get something new from them as well, something we didn't know. So we test it out. Maybe it works the device, maybe it doesn't. I always like to see how different fields work. So we'll have to test everything. Yeah, Lord help us. Might all start seeing little green men, huh? Let's see. Are you planning on making copper sphere negative polarity to suck the energy in the sphere? So, interesting question. We can always change the spheres. First of all, I'm going to go aluminum, and it has to do with eddy current bismuth. And the second thing is the outer layer may be better in copper, may not be. I don't know. I would definitely have one sphere to try in copper just to see how it interacts with everything. However, I think it's going to have maybe a worse reaction than everything else because it tends to hold energy in more than it does bouncing it out of it and forcing the field to stay off of the metal itself. You see, aluminum's kind of cool in the fact that it wants the energy to stay off of it. It does not like the radiant energy. It wants it to stay off of it. Now, everything can be overcome with saturation, but just in how it works is the interesting part. So copper is a possibility. We may start with copper tape and see how it does, or if it does anything, and then move on to something more expensive. If we see something in there that's a positive result in any way, then we would look to purchase that. But guys, remember, shoestring budget, so we have to keep each test, a little bit cost effective on this so that we can, only do the ones that we know we have something good with. So we'll try the tape, see what it does, and we can go from there. Yeah, surface area. I think T.T. Brown said something about bismuth, but I remember seeing it somewhere. Yeah, T.T. Brown, guys, he's building capacitors. He built multiple capacitors and plates. I mean, that part was very, very obvious. The part's not obvious is using radiant energy. And it's what he had to in order to make that thing go. Now, one of the things that you may not know, and I'll take this down, radiant energy has an effect on plants. It'll make them grow. So that's something that's not really well known. You put the energy into the ground, it takes out the the voltages that go into there, and it puts pure frequency into the plants. So when you have one of these fields sitting over top your plants, they're going to grow faster. I know that Plasma Channel did stuff on plasma, but the plasma after a while heats up and it kills things. Cold plasma, same way. Plasma is kind of a misunderstood thing. I saw somebody go on for hours today about plasma, and I don't think they really understood the true meaning. You need the resonance. The plasma is a holder for the resonance. It's not necessarily what you're looking for. You need the resonance. So, yeah. Science is awesome. Yeah. I suggest use a mirror in your mind, and your mind will detect the smallest differences. Let's see. Okay, so let's talk a little Egypt real quick. Take the Aken. It's the Egyptian cross. Put a mirror in the middle of it. What do you get? Well, on one side of the mirror, you're going to get a cross. On the other side of the mirror, you're going to get the infinity symbol, or an 8. When you put them together, you get the center of our planet. That's what it builds out to be. And it looks like our whole, universe builds out that way. So just so you understand, ancient Egypt had it right, and there's a quick way to see it. Putting the mirror right dead in the center, make sure it's a two-sided mirror, and you can get some information out of it real fast. You want to learn formula out there? Put the mirror in it, then put it in 3D, and then you'll start to understand the formulas. There's a hidden message in the whole thing in Egypt. If you knew that, it's just like saying, okay, now that you understand that, the Aken was the resonance symbol, so you put it next to bees. Obviously, bees are attracted to the resonance, right? Their hives, resonance everywhere. Then you go, okay, your plants grow with resonance, right? So that makes sense as well. Some of this stuff is pretty easy. The things look like Tesla coils. What do? They always put the resonance symbol next to them. They always put things that look like tuning forks next to them. Guys, this isn't difficult information to understand. They were telling you something. So anyway, that's just my rant about Egypt. They gave us all the answers. We just didn't realize how to read it, guys. That's 100% fact. There's no way of getting around that. Talk more on your thoughts of plasma, please. So plasma itself is the use of energy. Now, how do you want to use that energy? So if I put plasma in a vacuum chamber, right? It's going to build up as plasma and vacuum energy, but it's also going to build out a field on the outside of it, like a static field. That's what a lot of people don't know, because they see plasma in a chamber that's completely run with aluminum around it that's pretty thick, so that they can suck out as much air as possible. But when you put it in glass, you start to understand something different. It has a little bit of a static field on the outside of it. You're putting plasma in there for that reason. So that also means if you want to connect your Tesla coil and get rid of the discharge from the top, you need to put it in a jar and suck a vacuum out of it. We all look at Hutchison stuff, but I don't think people realize really what he's doing there. He's not trying to put plasma in the air. That would just ruin everything. They go, but it ionizes. Not what you really want. It's not the effect he's looking for. I mean, think about it. Let's talk about the stuff that he does. A Tesla coil. You put 400 volts into a Tesla coil. You need the field of the Tesla coil in hot energy. So he's taking directly the outside field of that Tesla coil. Okay. It's a radiant field. It's also scalar. Okay. And it's the same thing in the center, except for the center is negative and it's cold. Okay. Those are the two differences in the two. So Hutchison's using hot energy. He takes a discharge from the Tesla coil, puts it into a vacuum jar, and he doesn't allow it to ruin the whole experiment because it would stop the experiment from working. The discharge is necessary, but it also has to be contained in a certain way so that it's a very small amount of discharge, not a big one. You can't stop it altogether. You need that to be able to pulse the field a little bit. Now, he's also using big static generators in there, which is no surprise. You're doing the same thing in cold energy, but the amount changes. So the differences in hot energy and cold energy is basically the amount that you have to put in them to get the fields to work. On the Tesla coil for Hutchinson, you have to put the coil up over 1 megahertz or more, and you have to be able to build it to pump in a lot of energy. So when someone says they want a 1 megahertz Tesla coil, well, you could do that with very small wire. If you want one like his, you're going to have to build it out bigger wire, bigger coil. It's going to have a lot of windings, and you're going to have to build it out super hot. So the effect there is he has to take the room into account. You'll notice he says keep all the equipment in there because it's basically metal. Well, he's going to energize that stuff right there, all of it. All of it's going to become hot. And it's because your Tesla coil, if you've ever put it at 10 volts and got it in a pure resonance, what does it do? It heats up all the metal in the room. Now, it's not hot per se. It's cold, but the high RF makes it hot to the touch. You'll burn your finger. So he's going that in there too. This thing is spilling out and leaking everywhere. It's in an apartment, it's leaking. If you say he's in a container that's metal, then it holds it in. You're going to get a much, much better effect that way. It's interesting to understand that. And people talk about it, anti-gravity field, the A field and the B field. One's hot, one's cold. Cold just basically means room temperature and below. They're both there. It's not hard to understand. One's human can be around, and it's fairly safe. The other one, it would be a miserable, hellish nightmare to get into something that was run on the hot side of energy. It would be impractical. And the cold side's much, much better, and it's a much stronger anti-gravity field. Both of them have to build out the field bubble. You have to have static, and you have to have a radiant field. There's no two ways around that. That's the way it has to build out. Both built the same way. It just depends on the amount of power and the frequency that you put into it. When you go to a cold energy, the frequency on that Tesla coil has to be much lower. And I don't think a lot of people picked up on that yet. They will. But it means that, like Jarvis likes to say, the bell rings longer. Means the energy is sustained in the field longer. Therefore, you don't have to continuously ring it so much. Hot side, you do. So it's just an interesting thing. The plasma itself is a field killer. If you start creating open air plasma, I mean, you're putting something in there, man, it's just going to kill your experiment. And it's because it's ionizing the air, which is not what you want. You want the static to stay pure. You want the radiant energy to stay pure. If you wanted to put in the plasma, that's a field flip. So what does that mean? So if I was looking at Edwin Gray's device and he has a gray tube and I'm building fields, right? Well, say you build the first tube, the second tube, and a third tube. Well, on the second tube, I would connect that to a DC flyback where I can flip it with hot plasma right there. Just a field that goes red hot on it, and boom, it takes everything in there that's cold, immediately makes it hot, and as soon as you let off it, boom, it goes back to cold. That's exactly what I would do with that. That's how to do it. So, yeah, we know what's causing this stuff, guys. We completely understand it. That's why we're building this device. We can do it both ways. Just one's not tolerable for humans. If you put it in hot energy, be in a lab. Keep all the safety equipment on you. Everything you can do to protect every part of your body, do it. You know what I mean? This stuff, by the way, lead slows it down, but it won't forever. So I just keep that in mind. I mean, they make cold X-rays with Tesla, hot X-rays. Which side of energy do you think they pulled to make this sucker work on the cold side? Wasn't that hard to figure out? You use the negative rated energy. I call it negative because it's on the inside of the Tesla coil instead of the outside. So I think we need to keep it very cold. I absolutely agree with that. And it'll cool down just by the room itself. So I don't think people understand this. You don't want to cool this device down. You want to find that the air that's pulling through this device cools it down. And that's how you know it's working. The colder it gets, the better it is. So it's going to pull the most mass energy out of there because you're not hitting a loss. So think of it this way. When you turn on the heat of any one of your devices, the heat itself radiates out, right? It's a loss, complete loss. That heat is a loss. As soon as you do it, it'll make your magnetic field strong, but it'll make it very weak in the amount of energy it keeps. You keep it cold. What happens when you keep it cold? The energy's trapped in there. That's an interesting fact. So as you trap the energy into it, the more energy that flows through it, it keeps adding to it, adding to it, adding to it. You take the original amount and you add to it, right? It's that rotational field. So when these spheres build out as a capacitor, remember, I'm taking a capacitor. You can think of it like this, okay? Here's your capacitor. All in here is static. My hands represent the radiant energy field. I am simply holding it together. If I were to stick something down there to pull out the energy, it would be a higher amount as the thing grows, as the field continues to grow in the room. It's a proven fact, guys. That's how it works. I've seen it. So, I mean, you can build fields one on top of the other. You do it in geometry coils. So to do this in a spherical coil is not that difficult. We just have to understand what we're looking for and build it out properly in that same way. Now, we won't be putting a rod down or anything like that, but the whole point is, can that field on the outside that comes out in radiant energy, as it swirls, okay, it'll start to compress a little bit upon that static. Now we're creating pressure. If there's pressure at each layer, now the outer pressure becomes big. As long as that radiant energy can hold in that static, then we're going to start getting a thicker and thicker field out of it. That's what we're looking for. See, the gravity flyer just couldn't get the thickness out of it. I've tried it a billion different ways and couldn't get it out of it. There was no compression in it, so we couldn't get it. Yeah, keep it close to absolute zero. To be honest with you, it's going to go a bit under. I always say right around 5 degrees under is where it probably should be. If it goes down any colder than that, you've got a really, really good field going. Let's see. It's cold coming into the solar system. Well, there's no heat out there anywhere else, guys, except for in the solar system. I mean, think about it. You think it's critical for lift? Yes, 100%. I think it's critical for lift to keep that temperature, being that we're working on the cold side of it. Yes. Cold ether, yes. Let's see. I also suggest doping electrodes with ether, noble. Oh, really? Oh, sorry, monatomics or directional monopole. That's an interesting thing. I'm going to have to default to Jarvis on that because Jarvis usually builds that stuff out. Cold lasers. Well, not quite much into lasers, but yeah, if you wanted to make a field propulsion, then yeah. But you would also need to create directed energy with that laser. So that's a whole different topic all into itself. But there's a way to do it, and I don't think that mainstream science caught on to that yet. Oh, let me see. Jarvis says got it in the patent. I think Daniel Foster is talking about his device. Jarvis is talking about his patent, by the way. Both may be working similar, but probably not the same thing. Yeah, I don't care about Bitcoin. Let's see. Sorry, guys, I'm kind of behind on the chat a little bit. Something's a great suggestion. Okay, seems you guys figured out your thing. Sorry. Gotcha. Okay. Sorry, guys. I'm trying to read the chat at the same time. It's a little easier with somebody else with you because then they get to talk and I get to read the chat while still paying attention. I tell you, my wife has ADD, guys, so I'm kind of used to 2 things at once, 3 things at once. I always tell people I got like 4 conversations going on with my wife at the same time. And let me just tell you, I don't win any of them. It never works that way. I once took a cardboard cutout. I used to work for a soda company. So they had little statues of people. I taped my face to it and told her to have a conversation with that. About a week of sleeping on the couch. And then, everything after that. It was funny, but it was the truth because that guy didn't win any conversations either. So anyway, that's pretty interesting. Yeah, but what we're going to look at, guys, is simply going through some of this, man, and working it step by step. And I think that's what's fair to do. I mean, why jump to the end when we got everything we can, look at individually? That way, the cheaper the parts are, guys, the better it is. I think it was 8 pounds of bismuth, and it was right around 100-something bucks, so that wasn't bad. So I ordered that. We'll have to mold it and see what happens with the crystals. I know I was talking to Joe about this. We'd like the crystals to form. But then again, is it that important for them to form? So I suggested taking 2 aluminum spheres, fill a hollow cavity in there, and just pouring the bismuth in. He didn't like that idea as much. He wanted the crystals to form. The problem is we have to put the outer container on that container as we build it. So how physically can we get it done at that point? You see, I'm okay building, a sacrificial spot to pour it into and then moving it over, though I think they may be brittle at that distance. So I don't know which one's the best. Can we put frequency on the hot side of it? Absolutely we can. We'll just use some unconventional diodes. We'll take a razor blade, we'll burn one side of it, and then we'll run the energy right through it, just like an old school crystal radio. You know what I mean? They used to do when they dig out their foxhole. So we can do that kind of thing in there and see if we can't get the frequency to travel that way. Yeah, it's kind of interesting, guys, on how to build that out. I think there's a million different ways to do it. My thing is let's, I'd like to pound out a plate and put it in there and get it as tight as I can to that aluminum and see if it works. And then it may just make it lead. I mean, at that point, you never know. But, we'll try everything possible. If we can get the crystals to form, let's do it. So, yeah. That's right. Like those old school radios, man. Those people knew what they were doing. So more than one way to do things, guys. So yeah, quartz, dude. Let me tell you something. Okay, so we talked about quartz too. If we create a container layer that has a quartz crystal in there, or say even a salt crystal, and we want to grow that out, we simply need just to put warm water into it, plug the hole, and then run this device. In there, the energy may heat up the water itself over time and continue the process of restarting the growth. Or it might just grow out if we leave it in there for several days. We may have crystals in that layer. That's a cool option in itself, man. I would like to test out some crystal or some salt, see what the times it takes to build things out. Will it grow when you're spinning it? Does it have to be at low speed? It could be just like some of these Tesla coils, man. You put the goop on there, you know what I mean, as you're rotating it, and it just sits very slow and at self level. So is quartz kind of the same way? Do we need to make sure that we create something in there to grow differently? I don't know. You know what I mean? A lot of this stuff is small test, bring it to the big machine, test it there. If I can figure out a way to bench test it before it goes into the machine, that's even better because the geometry of a sphere sucks in order to play with every day. If I could just take pipes, put them together, create the cavity inside of those between two different size pipes, and then rotate it, let the thing build, I'll try that. Look, if I could do it with bismuth, I will, and see if it comes out crystallized or not. And I guess the best way to do that, and like I said, sacrificial stuff, we'd have to take a clear plastic pipe, which is PVC, and coat it with something that has a very good heat rating that's clear. And then maybe it won't burn it since bismuth is a low burning temperature. Do we pour it in there after it cooled just a little bit in order to help it? That'd be an interesting project in itself. Would you be able to see the crystals at that point, or would they be covered on both sides? What would the frequencies be going through it? We could definitely add frequency to a pipe like that. That's not difficult at all. So a lot of different ways to do things. Trees speak that way. Well, cool. I like that. Just to read how much crystal grew. Well, see, that's what I'm saying. That bench test would be perfect then, right? How fast did it take to do it? Can we expect the same results in the next project? If we can determine that, then absolutely. That would tell us where we need to be before we stop it so we don't prematurely stop it. We can check the capacitance of the part that we put it in, and we'll know exactly what it's going to take. So that calculation would not be that difficult in order to pull off. So yeah. What melting temp of business is a lot higher than PVC. Yes, it is. Yes. But understand this, it's like pulling out your chicken nuggets when you had them running at 415, guys. You know what I mean? Then how long does it take to cool down where you can move them and eat them? I mean, so the next thing would be, how much does it have to cool before it starts forming the crystals? Do we want the crystals to form a little bit before we put them in there? So it may be, yes, 500 degrees, I think 600 degrees, somewhere around there that bismuth melts at. Do we need to get it down to about 300 degrees? And could high temperature paint, clear paint for your engine, right? 400 degrees is what it says, right? Can we do it? Do they have one that goes 1200 degrees where we don't have to worry about, we can pour it in right away? You see, that's why the coating is important, because the PVC won't hold up. I'm well aware of that. So that coating may be important. Like I said, clear engine paint, do they make it? I mean, they make every other color. So that'd be interesting. Yeah, the calculations on everything. I think I'm going to be spending time with Jarvis on this one. So, but yeah, math is easy, guys. Just replace the letter with the proper number, and in the end, it all comes down to multiplication, division, addition, and subtraction. That's all it ever comes down to. And then the other stuff, it's a button on a calculator. It's not that difficult. Most of these people have calculators do everything for them. They just put in the first equation and it runs the whole thing. A lot of the stuff's online. You can buy a $400 calculator to do the same thing. Let's see. Jarvis was talking about automobile paint with Teflon nozzles. Teflon might do some stuff in there in order to make the electric. Now, here's the thing. You see the way the spheres are designed, right? We got that stud layer. We know exactly how thick it is. Layer after layer, we can keep it right there. Do we want air in there or not? I mean, the outside pieces will stick to it pretty easily, right? And then they'll be able to go from other sides of it. So that may not be that hard. AI, Nathan, yeah, not for me. AI can make me some pretty pictures, but it's not going to tell me how to run an experiment, that's for sure. AI is not my friend. So the fact that it has no idea what I'm talking about. And to get it up to speed would take longer than it would to build it. Calculator for an engineer, yes. Flame stayed very close to crystal. By the way, did you see some of these experiments they have out there with crystal? They're trying to get them to light up, right? So they put high voltage to them. Well, high voltage doesn't work with crystal. It doesn't at all. It goes right around it and goes over the spark. And it looks nice. It looks like it's lightened up, but it's really not. It's just the voltage itself going over it and creating the light from that high voltage and the plasma it creates. And it shows it in that way. Now, I have seen a crystal light up when somebody took a drill bit and put it into it because they're creating pressure into it, and pressure does work. So one of those things compressed is good. But I also saw Sean do something one time with his Tesla coil. He flipped the field in it. And what did it go to? See, this is the most interesting thing. It immediately attacked the geode that he had, and it was quartz. Now, that's not normal. You don't have anything else taking that reaction. It's one of those things you put in your brain, you circle, you go, we're coming back to this. Now, I bought a pretty big geode, guys, because I want to test that very effect, because that wasn't a normal result. You didn't see that everywhere. And what it has to do with, he's flipping that field inside of a testicle. Again, the same thing I'm doing, which means it's going to interact with that geode. The only thing it's missing is water. I mean, think about that. The guy got a result that no one else has seen yet, and it's directly related to that. Now, if we put the geode under pressure, put it in water, and put that energy in there, what would it do? That's what I want to find out. So I want to build one of his Tesla coils just to find out that answer, because I'm thinking right now, guys, that's going to be the key to make it work. So anyway, that's just in that part of it right there. Sean's Tesla coils are awesome, by the way, and nobody's going to top him. You know what I mean? I just haven't seen it yet. The guy's so inventive. The geode lit up. So I don't know that the geode lit up. Not yet. I don't think it had the proper environment to light up. I think it needed a little more compression. But the energy went directly to the geode. Usually, high voltage, if you put it out there, it won't go near a geode. It's the wrong type of energy. They don't mix. So they stay away. This one went right to it. So it just kind of told me, hey, you know what I mean? There's something more there. And if it goes to it, it means it must produce something close to the same energy or be built of the same energy in order to get there. That means that negative radiant field has to be in the earth somewhere. That means we're working with the earth energy, guys. That's the important part. So think about that. If we're building that field that is the same thing as the geode, it means that we're right on track with the magnetosphere. It's exactly what we're looking for, right? We're not going crazy for something else. It's what we wanted in the first place. We wanted to combine. Now, some of the other things that it wouldn't attract to, it wouldn't attract to the crystal cylinder. And that's kind of different, right? Because we see the crystal cylinder, and usually Tesla coil, by the way, will attract to it very easily. It's just told it was on opposite sides. Yeah. By the way, guys, not a lot of people have ever seen something like quartz light up. This is something that's biblical. You know what I mean? This goes back to the Ark of the Covenant, when they had that little shield that the priests wore, and each time something lit up, it was the right frequency, it was the right energy, right? Well, it kind of also goes to some of the devices the ancient Egyptians had. So on each level, they had crystals in their staff, which was a tuning fork. The tuning fork could have just been put in the ground and correct the sound from the ground, and then light up each one and tell you which field you're in. And that's fairly easy, okay? So if we're looking for something like that, then yeah, that's it's a road to get there. And it's one of the only avenues we found to get us there. So, by the way, anybody that figures that one out before me, by all means, show it. You know what I mean? We'll praise you all day long on this channel, because that is an amazing feat. Okay? That's going to be directly tied into every science available coming up. By the way, for those who haven't figured this out yet watching this channel, I hope you do figure this out. Everything in this world is based on the structure that a geometry builds, the frequency of it, the octaves, the notes, all of it. Okay? The sounds. Sound is movement. Okay? If you take frequency, You need sound to move it. That's why they put the tuning forks in boxes, because the boxes create a chamber in which the sound can now move. You tune on a turning fork next to another one, move it a foot away. That thing's hard to turn on with the other one. You need that box. You need that sound to move it. Some of these things, man, you just got to realize what they are when you see them. You know, I think it's purely fascinating that a lot of people didn't know that. They think, oh, man, we'll just turn it on in the room. We'll hang out over in this corner and they'll turn on. No, got to have sound. Got to have sound. Sound traps things. Sound traps plasma. Okay? Think about that for a minute. If I took a bunch of speakers on those little speakers, right, on the little levitation machine that they make, and I put plasma in there, just a little spark gap, what happened? It gets trapped in between the layers of the actual sound wave. And then you can direct it like this as you move those speakers and sound. That's an interesting effect, right? It's telling you that it's going to move the frequency in there. It's tied to that frequency in each layer. It's not tied to that plasma. The plasma, like I said, is just a holding conduit for that frequency. So you can reduce the amount of plasma. So what you're going to do is you're going to take down those amps really, really far. And you want to get it almost to a static plasma. Then move it with sound. That's the way to make it work, man. Yeah. Yeah, a lot of people didn't realize that. So, Walls of Jericho, man, saturate the field. Saturate it. Move it with sound. That's how a lot of things are done. Why do you think the monks put the thing in the rock in the bowl? They create the frequency in there. It's like a resonance chamber. Then, what do? They move it with sound. They create all the horns in there in order to make a frequency. Now, we'll get back to the crystal a little bit. Geometry is frequencies in there. It's more than one. But as long as you stick to the musical scale and hit the right note, you're fine. So if you go on a scale of A, okay, 55, then you add 55, get 110, but then you add 55 again, what does it get you, 165? You see, it builds out just like that. It's the same thing as 369. 3 plus 3 is 6, plus 3 more is 9, right? The next number after that is 12. It builds out in the same scale. So now when we're looking at this stuff, we're looking at the actual frequency building out the same way. Hit one tone in there, you're going to hit them all, okay? And that's the way it works. It works out in a geometry pattern. Now, the geometry pattern builds out, and it builds out. You see, everything works on that. So when we get to understand everything, guys, you're going to find out very easily. The world is so consistent on this, on frequency, vibration, everything. All you have to do is hit the right resonance frequency, and then guess what? You're going to get plasma out of your Tesla coil, number 2 coil, with nothing attached to it. Why? Because you hit the right resonance frequency. You see, the coil, you go, well, it doesn't know the resonance frequency, but when you test it, there's a frequency to it, right? And you go, okay, well, can I take the Tesla coil I'm working with and set it at that frequency and get the other one turned on? Oh, the answer is yes. And when you start to get that, you're going to have to turn down your original Tesla coil. Here's the crazy part. Everything in your room, the closer to truer they both are to the same frequency, the hotter every piece of metal in that room gets. It's the way it's working. You're putting a ton of RF in the room because you're bouncing it off another coil. Now, create a triangle. You're bouncing it off 2 extra coils. It doesn't care. You're ringing the bell. You're ringing it in both the coils. Exact same way. You could force resonance into your primary coil, but you won't get the same result. Tune it by taking off the layer by layer by layer on that coil. Guess what? You're going to truly ring the other ones. That's when you get your energy out of them. That's when the plasma starts. Guys, I showed it from 2 feet away. I did it at 5 feet away. I can get plasma right out of that coil 5 feet away. That means basically, was Tesla available to put in the air? Yeah. Would he have done it that way? No. No, he wouldn't have. He knew it was not going to work. It wasn't until he discovered the negative side of that energy. And then what did he do? Well, under Wardenclyffe, there's a giant amount of copper underneath it. with that rod going down the center. He literally put it in the water table to go through the water. That's what he did. That's why the light bulbs lit up attached to the ground, not why sitting in the air. I think a lot of people miss that one. They go, well, if it's a Tesla coil, turn it on. You can walk anywhere in the air and turn it on. That's true. But why didn't they light until they hit the ground? Well, it tells you that he ran his field in a different way, didn't it? That he was doing something you didn't realize he was doing. He put it in the ground with a massive amount of wire in the ground. Now, there's an energy company out there that wrote a letter about this, and I can't find where it is, but it's definitely written down, and it says that he did it. So think about it. Put your rodent coil in the ground. Now attach a wire to it. Put it in the water table. So if you got one of these, water areas in your yard where it builds up water and rainwater in the rocks and stuff like that, put it in there. Okay, let the water flow through it. Let the energy flow through it. Attach to the center of your Tesla coil. I can tell you right now, you're going to get a vortex out of here. I can tell you right now, as it sits in water, it's going to actually cool down even more. And when you get that vortex in there, the energy is going to stay in there longer, even if you detach the Tesla coil completely. I've done the test, guys. It works. Put it in the water, it stays cooler. You originally start out with something that's cooler. Okay, that is the temperature of the environment around it. I always say room temperature. You can replace that by saying environmental temperature. Well, in the water, it's the environmental temperature. Now you can start to see how that right there and Hutchinson stuff works. Put the frequency in, what happens? Everything swirls to the coil. Everything pulls in, okay, that shouldn't be there. It attracts everything with frequency and pulls it in. One of the coolest things that I think is possible that he did, and I don't know that he did it, is if he actually transformed the stuff inside of something like that. You see, that's one of the most, one of the things I wish I knew the most about what he did there is that he actually do it like the thunderstorm generator. Was it able to pull everything apart and then put it back together in different forms, same form? How did he do it? Guys, that's one of the things that we all want to see, okay? Once you see that, you know these coils are absolutely the right thing you need. Now, different geometry coils, guys, do different things. So you may see them in 2D, right? You go, well, they're just layer on top of layer on top of layer. Well, they're not really. They're more of a built-out geometry. You see, you may have a hexagon, and you say, well, yeah, it may create a hexagon, but then the geometry, when you put it into a big form, it looks different, right? Well, yeah, it does. Put it in the shadow, it looks like the hexagon again. Okay, well, why is that important? It's just like crystal structure. The outside of the structure, the crystal looks a little bit different, but the inside is still built with hexagons throughout it. I mean, think about that. It comes to a realization that you're not just building the geometry, you're building a bigger geometry than what you're doing. So you go, well, build out triangles, right? Okay, you're going to build out a Merkaba. You may not realize it right now, but you will. That's what you're going to build out. So, yeah, I understand Jarvis Diamond. By the way, the diamond structure, when they show you the, how do I say it, flower of life, stuff like that, right? Oh, God, I'm not talking about the flower itself, okay? But when they show you it in a geometrical pattern, say it has 3 dots this way, then this level 3, then this level 3, and they combine them down, stuff like that, right? And it looks like a crystal format. Well, that's a diamond format. That's how diamonds build out when you put them together. And they build out of that based on where the oxygen goes. So very important to note that. Also, man, a lot of these things work this way. Everybody like that water car when you see it? So he separated the oxygen from hydrogen, right? Well, you have to know in order to pull that oxygen in, how you have to do it, what form it has to be in. That's why in that thunderstorm generator that ionize it first. But they're not putting straight plasma into the water. It wouldn't work. They have to put it in a light bulb. Okay. Again, think about that. We just said ionize, but we also said put it in a light bulb, which is basically a vacuum chamber surrounded by glass. Think about that. So when I tell you about Hutchinson, and I tell you about the thunderstorm generator, understand we're getting the same effect. Okay? He's looking for the same thing in ionization. He's not looking to run raw plasma out the top of the testicle. Think about that. It's kind of an interesting correlation that you should look at. A lot of these inventors are using the same thing over and over and over again. They call it different terms, so people get lost. They get lost in the terminology. That's why describing what it's done instead of saying the name of it is a lot easier. You go, if I tell you how a process is done, I'll get 5 different answers on what the actual process is, right? And it's just based on your understanding and who you listen to. But if I tell you how it's done, it's very easy to understand that way. You go, okay, it may be this to other people, but to me it means this. So, but I'm still getting the same effect out of it. That's why it's important to do it this way. It's like an engineer talk, right? You could tell me every different scenario in the world with everything, but the processes don't change much, okay? Tell me what you're actually looking for, I'll build it. Tell me what you're not looking for, I'll make sure it stays out. That's as simple as it gets. That's how an engineer's mind works. You don't put in the extra words. You don't need to. Just tell me the exact things you're looking for, and that's the way I build it. So, yeah. Let's see. Wow, I'd like a diamond that big. Not what I meant, but okay. Yeah. Yeah. My gravity flyer forgotten. I think, honestly, it's something that I get back to. It's not something that I am messing with right now. I put it aside for a reason. And the reason is very simple. I want to try out, see what bismuth does, because I may be replacing that center plate with bismuth. It looks exactly like aluminum when it builds out. I need to see the effects of it. So I have a very distinct feeling that he was using that instead of this, and it has to do with diamagnetism. So revisit it, yes, but not until we figure out some more steps. I think sometimes, guys, we all want such an easy answer, and it doesn't come that way. Sometimes you have to build other experiments to find the answer. Like, I went on the Tesla coil thing, right? I wanted to figure out why we put the rod down the center. Well, we figured that out. We outlined it. We found out why the energy's there, and now what fields are worth looking at. But did it lift that gravity flyer? No, it didn't. So when we change out the center disk to something that looks like aluminum, but it's bismuth, will it do it? It has the right things. You talk about Grebennikov, you talk about the cavity within, the crystal structure. It really has what you're looking for. So, I think coming back to it at a later date's a much better idea than trying to force something every day. And with the thousands upon thousands that I've done of testing, it's telling me that there's something wrong. And look, I've reworked the Tesla coil, reworked high voltage. I got all kinds of awesome results out of that gravity flyer. I learned how to build fields out of that gravity flyer. I learned about beat rates in it. We learned about a lot of things. We found the anti-gravity field. We found it. It's there. 100% there in the gravity flyer. Something's wrong with it. There's something wrong with it. And we know he didn't use copper in there. We know he didn't use something else because he used a plastic. Would it have worked with 2 plates like this, like he showed in some of the work he did, with a plastic plate in the center in order to create capacitance, and then force them so close together, but that the seals on the outside of them here and here won't let them go, and then pop them apart quickly, which will happen, okay, if you use that piezoelectric buzzer. They will pop apart, and it will create a massive amount of energy. It'll go in there for anywhere from 9 volts to 1,000 volts easily, okay? So my question is, did they get the plate wrong in the center? And I know Charlie C. I know he's 100% right in what he was sent, but I also think there's something missing. And sometimes you got to get to the end of the road and ask the question, did we just get taken? Was there something missing that would never let us do it? Did he have to hide it because of where he lives? I don't know. So yes, I'll get back to it eventually, but right now I have to do all these different experiments on this other stuff before I get back to it. But the day that it lifts, you're going to see a simple thing. It's going to say Old Man Builds. It's going to say Gravity Flyer, and you're going to find it. You're going to see it. And that'll be the day you know I have it right then and there. But yeah, until then, I'm not comfortable in doing any of that. Yeah, I like Charlie. Charlie C's one of the best people I've ever met. He's a really good guy. By the way, props out to Charlie C on his Tesla coil. When he put that water in there, into the coils, by the way, with that pump from a computer, and then he put lights on it and stuff for the he put some LEDs and stuff in there and lit it up and a different color fluid going through it. I know it's an aesthetic thing, guys, but I absolutely loved it. It was something different, made it look cool. It's like pimping out your computer with all those different colors and stuff and the pumps. It was just aesthetically looked absolutely amazing. Yeah, Charlie C's a gentleman. Charlie C's a good guy, man. I owe him one, man. So he asked me about a Tesla coil, and I'm going to build it for him. And I asked him which project, so I knew which one to build them. They're different, for a 1 megahertz Tesla coil for relatively, you know what I mean, for negative energy than positive. So they'd be completely different builds. So, let me see. What about a ring instead and the plate quartz? You could put quartz, but quartz isn't going to interact the way you want it to. You got to remember this inside center is a cold electricity field. Bismuth works perfect. They're both diamagnetic. So that's why they amplify within one another. You're hooking your Tesla coil straight to it. So it's going to have to be something that your Tesla coil can connect to. And it has to be able to amplify once you put it in there. Well, quartz will do it. It'll get you there, but I don't think it's the right material. And you got to try as true to the emitter as you can. And that's why I want to use bismuth, because it looks just like aluminum and really fool everybody. But the reaction is way different. We need to go to the alloy saucers. Skunk works. Yeah, Lockheed Martin. By the way, guys, all we need to do is find out what works. It's not so much about the materials afterwards. It's about what works. So if we find that, we get aluminum to work, right? Can we go to titanium? Can we go to the next level of that? Can we get something like that? So that's what we're looking for. We need the interactions first before we go with a higher value, thing. Because one thing I caution everybody about, do not overpower something until you know how everything works. The second you do, you'll get false readings and the whole project goes downhill. You'll have to immediately pull everything back out and start over again, because you overpowered something, man, that wasn't supposed to be overpowered that way, because it had multiple functions. You see, you start overpowering it with the eddy current, with the magnets, it goes way too big. You'll get the eddy current, but you're going to lose some of the frequency in the process. You get totally different frequency, totally wrong way to go, right? You put in the high voltage, you get way too much voltage going on in there, right? It's hot. You make a magnetic field. Kills cold energy right away. Right from your Tesla coil, flips the field, immediately turns into hot energy in the center. Complete loss. When you can do this and understand why they're doing things, then amplify it once you understand it. That's all I'd say. I love building things out with better materials, but I need to know why it's doing it first. So, yeah, weed out all the bad stuff. Yeah, I'm there with you. Let's see. Gotcha. stable version of which one is that? Moscovium? I'm not sure what the word is. Would be nice. Okay. Yeah, safety first. Yeah. Look, everything's better. Let the old man on your screen do it first. But there's your warning. Okay. If I'm around and kicking the next day, we might be all right. Okay. Element 115, if they can make it stable, they haven't figured out how to stable it. Well, they might have now, but they didn't back then. I'm not falling down a rabbit hole with that. I'll be honest with you. I don't think it needs it. So I think this has more to do with resonance and layering than it does anything else. And once we figure that out, it's game over, guys. We already have it. I mean, think about it. We already have the outside field. We already have it. We're looking for thickening of it and propulsion method. And we need the propulsion method, which we could already have in the bifield Brown effect. That's fairly simple. Take your geometry coil and then put the little things on the outside. Turn one on at a time. It goes different directions, right? That's fairly simple. We can move a craft, all right? But we're going to have to figure out some of this other stuff first. We got to get that. We got to get it to build out like a capacitor, just like, again, bifield Brown effect. Build it out like a capacitor. It's going to leak a little bit, again, just like a capacitor does. And that leakage we're going to use into the next layer, into the next layer, until it gets to the outside, we can no longer leak. Yeah, I have. I've got blasted with a lot of different energy that didn't work so well for me. But I have a Geiger counter on the way, guys, so hopefully that'll help. I don't know it's going to figure out everything for us, but yeah, some of these things are best to let me do it and then figure it out after that. A lot of the stuff I took outside, guys. I didn't trust it in my garage. Once the field got so big, it got thrown out of my garage in some of it for some of the experiments because the field was unpredictable. Once you start shutting off your computer and you paid a couple grand for that thing, man, I'm sorry. You're going outside. You know what I mean? It's like your dog peeing on your floor all the time. You got to bring him outside. Okay? Can't have it happen inside. So, yeah, that's what I had to do. And then stay out of the area. So big, long cords to it. Yeah. The yellow cake, like the yellow snow. I think you're talking about some kind of nuclear thing, but every time I see yellow cake, I think of yellow snow, like yellow cakes in the toilet. Sorry. Just my humor. Safety first. Try it. Yeah. Wear rubber gloves. Yeah. Charlie. No, not Charlie. I'm sorry. Sean's real good at that. He has those rubberized gloves for the high voltage. I don't know how well all that works, but I can give it a try. The problem with gloves is, man, I got big old meat fingers. So when I start putting those things on, man, I feel like I can't feel anything. So, yeah. How you doing, Crypto? Hopefully everything's good. I saw you out in the snow this week, man. It's got to be miserable up there in Canada. I can't deal with the snow, guys. I got 4 screws and 2 plates in my back, and every time I go in something really cold like that, oh, does it ever hurt? I mean, yeah, it's like throbbing after a while. It's like standing in a freezer forever. He's just at work now. Yeah. I heard you're building a studio over there, man. That's pretty cool. Maybe cooking gloves, barbecue. Oh, that won't do it. That's not going to stop the high voltage. Yeah, good for smoking meat, though. I do agree with that. I do a lot of that on my barbecue. I'm an offset smoker. You know what I mean? Run your barbecue ribs on there and one with the offset smoker to it. Never let the heat come anywhere near it except for the rotational heat that it goes in there. That's always pretty good. By the way, guys, cooking again, I know I'm hungry. If you take your steaks, this is kind of a cool thing I do. You basically get your grill marks on both sides, right? Getting a nice sear on both. Then if you're running with gas on 4 burners, you turn off the center ones, right? And you put the outside ones on. You close the lid. It works like a convection oven. Now it'll cook the inside to a beautiful temperature. Okay. So it's like the inside when you sear both sides and stick it in the oven. And all you have to do is every once in a while flip it. Man, those things will come out just so juicy with those steaks. Chicken's the same way. If you're using charcoal, by the way, man, take your potatoes, wrap them in foil, throw them in the charcoal after it's started already. Put them in there. Make sure you had a butter layer on the outside of them, man. Oh, maybe a little bit of garlic right there, like, cut up garlic, not so much the powder stuff or anything like that. And then you put those in there, but you separate, the charcoal, so the center doesn't have direct heat on it all the time. And you cook your chicken that way. Oh, beautiful. It really makes a big difference in cooking stuff. So, yeah. I'm kind of fat, guys. I like to cook, so like to spend a lot of time. I have a huge barbecue island out back, man, that I built. So, yeah, temperature is important. Keeping it away, man. Steaks, yeah. Love some steaks, man. Or like ribs, you bring them in, you get some butter in there without any salt on it. You get your barbecue sauce, you whip them up together, you get some tin foil or some butcher's wrap. When you take out your ribs, you know what I mean, and you want to coat them and glaze them a little bit, you put that on there, wrap them back up in there, man, put it back on the grill for a little bit. Oh, man. If you like that sweet flavor, it's perfect. So, yeah, bonfire. Oh, trust me, dude. Bonfire, yeah, cooked all over that thing. Yeah, cooking sign of an alchemist. Yeah. I'll tell you what, man, you learn a lot right then and there. Okay. You want a happy wife and a happy life? Barbecue once in a while. Trust me, they love it. Especially because you're taking some of the workload off of them and what's going on depending on your situation for cooking. Yeah, my wife likes that. So I'll go out and barbecue. She goes inside, cooks all the greens and stuff. It works out really well. So, but don't get me wrong. Dude, I know we're talking about food. Cut up all your vegetables, and then you got to find like a lemon flavor mixed with a couple different ingredients, some garlic in there and stuff. It's like a seasoning. What you want to do is put these things in a pan and then put a little olive oil in there, kind of mix it up a little bit. You know what I mean? Get some garlic in there, get all the different kind of vegetables in there, sprinkle this stuff on top, put it in your oven about 30 minutes. If you like the stuff a little bit crunchy, if you're old and have no teeth, 45 minutes, right around 400 degrees, and you're going to get this beautiful, beautiful vegetables that come out of there, man, that are just awesome to eat, have a great flavor to them. So, yeah. Never trust a skinny scientist. Oh, man. Campfire group of, I'll tell you what, I'll make some steaks, man, melt in your mouth. All right. Let's get back to a little bit of energy, man. This stuff, although I love talking about cooking, I'm gonna get myself in trouble. Yeah, asparagus is nice, man. The only thing bad about asparagus is when you use the restroom or afterward, everything kind of smells funny. So, all right. So we'll get back into the energy a little bit, guys. So we're creating that device, but I also have a couple other things on the burner here, guys. I have a Tesla coil winder. So I built it out. Let me see if I can't show you. So basically it'll have these two right here that set apart from each other. The motor itself goes in this one. So it goes that way on the way through it, just like that. This side just gets a bearing in it. Pretty simple. But what it's designed to do, guys, will have a little switch on it right here. It's simply on, off, fast and slow. And then it has a potentiometer right here. So you can adjust that. So it'll still be a little bit of hand built. So you have to put your hand in there to guide it. I like to do it better that way. What's up, Lulu? So, yeah, I like to do it that way, man, because some of this stuff I like to see it. and I put my old lady's reading glasses on down to here at the edge of my nose like an old man because I need to be able to see it. But the cool thing is it all runs off of 12 volts, so we could basically take a power source for a computer, and then we could put LED lights on it. We could go out and get a lens that goes across the whole coil so we can see it feeding the whole way. Put little lights on that, man. Always helps. But kind of build it out and then see where it goes from there. You know what I mean? Because, man, I get really tired of sitting there with my hand and going like this in order to get this thing to wind. It's exhausting. So, yeah, 12 volts is all you need, man. And then it'll get you there. So, yeah, well, thank you, Lulu. I do appreciate that. Yeah, I sent Mike a message earlier in the week. I don't know that he got it. So I just talked with Mike actually a day or so ago, and somebody wanted to do an interview, and I figured Mike would be a perfect person for it. So I hope that works out. We had Heliarch who wanted to go out and do some stuff, and then Mike, in the way he does motors and generators and stuff, and Heliarch does the same thing. And, you know, Heliarch talks about the Meg and stuff like that. I figured it'd be perfect, man. I'd like to see Mike sit down with him in a nice conversation. I think that interview would be totally awesome, and I look forward to it if they can work out the details on that. So, yeah, good idea. Yeah, you know, because I know a lot of people probably want some Tesla coils, guys, after they see people build things. And I'm not much on selling things that I already built, but if it's just a number 2 coil you need or something like that, I probably could do that. I'm not looking to put the whole device together for you. The whole point of a Tesla coil is to kind of DIY it. You know what I mean? But yeah. Yeah, I hope they bring the Woo, man, because I'll be honest with you, Heliarch's awesome. I love the fact that he works on that stuff. So, yeah. Anyway, yeah, but I think the guys we have coming up, man, are going to be so awesome on the show. I think it's one thing that we're missing. Like, you guys see our experiments, right? But we're just a couple people, working at home with a little budget, working on things. So why not everybody else? I know physics likes to have a bunch of physics people on. Why not engineers have a bunch of engineering things go on? I mean, that's the way I thought about it. That's the way Joe thought about it. Jarvis, we all got to talk. Sean loves doing it, man. Sean's like the best presenter out of all of us. Everybody loves his presentations, man. And it was nice to talk to him one-on-one after that. You know what I mean? Kind of go over some of the stuff, man. See what he thought on it. See what I thought on it. Where we can go from there. Some of that stuff's just the coolest thing, man. No distractions, nothing. You know what I mean? Everybody's kind of just on point with it. And I think that really is the way to go, dude. So I'm really excited about these interviews. And then some of them, man, I'll be very honest with you. I don't know a lot about a subject. So if somebody else, you know what I mean, who we hang out with knows a lot more about it, I'll bring them in and help with the backstage stuff. And they can do the interviewing. And I think if it makes a better show, man, then by all means, let's do it. I mean, that's the way it needs to be done. And I'll learn some stuff in the process. You know what I mean? But what I don't want to do is ask a bunch of questions that are kind of out of bounds for it. And when there's better questions that could be asked. So, yeah, we'll figure all that out. Yeah, Sean's my favorite too, dude. He always, by the way, just so you know about Sean, he's like the best person ever. Like, he'll do the show, right? And then he'll message me on Facebook and he'll tell me, Nathan, thank you for letting me do the show. And I'm thinking, dude, thank you. I mean, seriously, I'm the one that should be thanking you. I mean, he comes on, he puts out, dude, 45 minutes to an hour. Coolest guy ever. Does all these cool experiments and has no problem putting his presentation together and talking about it and the ins and outs of it, man. There is no wall of secrecy there, guys. Just so you know, he's flat out. This is the way it is. We're not hiding behind anything. It's out in the open, man. That's why it's my favorite. You know what I mean? He comes on, does his thing, and like, dude, this is awesome. Yeah. Yeah, his attitude, man, it's like the best ever. Okay, just so you know. So I think it also gives him a chance. He always wanted to do a show here on YouTube, but he has some health concerns. Stop him from doing stuff every once in a while. But the fact that he gets to present here, man, is like his greatest part of his week, man. That's like the highlight of his week. He gets to kind of live out what he wants to do, you know what I mean? But not have to, be a workhorse for it. He gets to come on and do his segment, man. And it's like the highlight of his week, brother. So we love Sean around here, man. So, yeah. Yeah, also one of the kindest people ever, yo. You always ask, well, what do you need, Nathan? I have to tell him nothing. I don't need nothing, Sean. Sean's the kind of guy that you'll have something showing up at your door the next day. So we always got to tell him I don't need nothing, Sean. We're good. I like the conversation more than anything. Yeah. Maybe something I'm more a fan of. Okay. Right on. Yeah, dude. We got some cool stuff coming up, man. I think some of these projects puts everything in perspective. So you go, why a new project every once in a while, like throughout the week? Well, because you're going to see the same thing I'm seeing. So, like probably many of you, I look at all these inventions throughout the week and what are they doing? What is it like the last one? You see, my greatest skill, guys, is not putting something together. It's understanding why things function together. What is the next step in the process? That's what I do, okay? It's not so much that I'm meticulous in the coils. That comes from being a perfectionist like I am. But it's the fact that I'm looking at every invention, seeing what the next step is. Why do they interact that way? What am I missing? What do I need to see? Do I need to build it to find out? Can I ask the person? Do they know? You know what I mean? That's what a lot of you probably don't see about what I do. Man, behind the scenes, I must have asked Sean 500 questions when it came to a Tesla coil. Like, seriously? Because he told me one day, Nathan, I could build you a Tesla coil. It's going to work, right? And I go, all right. Let's see. So he gets with me and we start to build this Tesla coil, right? And he goes, well, where do you want to start? And I go, well, here's the things I've noticed about, where the frequency has to be. And we said, okay, well, we got to find a way to find that. So we went to Java Tesla coil or TC, and he literally mapped out how to do it, how to figure out how to do it in order to get the right frequency we're looking for. And then we tested it. We built a coil. We tested it. We tested it on 2 gauges. We went 32 gauge. We also went 28 gauge, right? We wanted to see if it would work on both. That's why I have a very tall Tesla coil and I have some very short ones. And it's simply that. We just wanted to find out every little aspect of it. So if you go, I have a ZVS, what's the frequency that I need in the coil? And we were able to do it that way, man. And that was the coolest thing. So he put that together with me, right? And he put up with me doing stuff. Man, let me tell you something. I like to race to the end. I fry it and find out. He's the exact opposite. He likes to check every little spots of it and not fry it. My bill is 10 times what his is, and his method is ultimately correct. I have fun doing mine. And it tells me the instabilities of everything. He says I'm the only guy that'll light something on fire and calmly walk over to it to put it out without freaking out. So if that tells you about anything, man, how I do this stuff, man, that's it. I fry it and I find out. And then the cool thing is, man, you start to see field flippings. You start to see all kinds of different things. You see different aspects of things that come out of it. Man, it tells you new techniques on how to do things. I once took my ZVS. I fried one offset of it. So what did I do? I just took the number 1 coil, right? Took the wire you attached to it in order to get the frequency. I said, forget this, man. It's already fried. I left the power on and ran it right across the whole thing until it pulled the right frequency. Then, once I had the right frequency, I marked it and went over, changed out the ZVS, put it on there, worked perfect. I called it the redneck way of learning how to do a Tesla coil. The ultimate fry it and find out moment, right? So, yeah. And then I also do things with different coils, man, when I built it. And Sean kind of tripped out on this. Why are you putting a rod down the center, Nathan? Well, I'm going to change the frequency. I'm going to lower the frequency on that Tesla coil. He goes, what do you mean? Well, I was doing a Tesla coil once, and I put the rod down the center to my gravity flyer. My gravity flyer dropped the coil at 300 kilohertz. And I go, dude, are you kidding me? Like, what's the deal here, right? So then I started playing with it like I do until I fry things. And sure enough, it changed the frequency of it. So just a side note here, Jarvis was talking about, we put the generator to it, then to the Tesla coil, and then boom, it hit me already. So when Tesla takes a wooden stick and puts it down the Tesla coil, what happens? That dynamo to the Tesla coil, he puts the wood down there. What is he doing? He's changing the frequency of that Tesla coil. Then he can suddenly release it and push a ton of voltage, man, and let it ring forever. So, man, just certain things that you learn along the way were cool. Yeah, just to get back to the whole thing with Sean, we went through it together, built the Tesla coils, man, they come out perfect every time. You can build them all day long the same way. And man, since I did the STL for the number 1 coil, let me tell you, this thing is absolutely a monster. It way better results. Used to be the coil kind of just jump around, bounce, set off the frequency all the time, and it'd be a real pain. When it's stuck and it can't move, oh baby, now we got something good, right? So that STL was just the ticket on that. And then I put a little, round circle at the bottom of them. So when I put the rod down the center, it stays straight down the coil. So that worked out perfect too. One thing I have to do to the STL on this one is I have to probably either burn a hole in the bottom of the one I got or just create a new STL. Either way, on the device I was working on, this one right here, because here, I'll show you real quick. That rod, let's see if I can't get to it. You can see it's going straight down that Tesla coil. It's going to rotate and go straight down that Tesla coil. How is it going to react by being rotated in there? God, I don't know yet. I should probably test it to the side, but yeah, we're just, like I said, let it rip. Yeah, let it rip. Let's see what it does. And it's going to be perfect, though. The rotation on it should be perfect. So I'm really excited about that one. So get the aluminum rings to fly. Yeah, well, I'll tell you what. If you make gravity well, man, the world's your oyster. Do what you want. You're going to have time dilation, which also means inertia's gone. And it sounds wrong, right? I didn't give her inertia. Well, time dilation is going to take care of inertia. That field bubble we're building is going to take care of inertia. Once you break gravity with your own gravity, then you can do what you want. The gravity is the field that you're in, not the field that you're not in. So, yeah, it's pretty much going to break it, which makes you wonder, is time different in the center of the earth than it is on the outside of the earth? Kind of an interesting concept now that you think about it, right? Would we live longer if we dug down and lived under that layer of energy? Would there be a society down there? Can we get through it through some of these the volcano tubes or something like that? Can we get through there? I mean, it's always an interesting concept. So if we do this, then people will be going, oh man, I got to dig that far down. I got to get to that energy field. They're going to know it's there. They're going to know it's there. I know it's there. I see lightning. I can see the tendrils coming up like this and the lightning coming down like this. And then one of the last experiments Sean did, we saw the exact same thing. Now, I wanted to be a little more dramatic about it. You know what I mean? Get some mud, put the coil on the bottom in the mud so you could see the tendrils coming right out of the mud, that would have been awesome. You know what I mean? I might try that on my own. Or, oh, it sounds like a sick joke, right? Let's put the negative energy from the center of the Tesla coil into the mud so we know it creates a field around it. But then let's just connect our light bulb straight to a light plug and plug it into the mud. It'll turn on the light bulb all day long. Yeah. But that'll just trip people out, right? Coolest thing. Let's get me one of those oversized plugs. Probably like the Matrix's standing wave, one side positive, the other side negative, and the Catman. Can it be? It might. Might just be. What's going on, Papa Bale? Dude, for those of you who haven't watched, Papa Bale's awesome. His pulse meter, man, awesome. I could watch that all day, dude. He's got that thing dialed in. He tries all kinds of different experiments to it. But puts the wires everywhere. I mean, he does all kinds of cool stuff to that thing. Like, it kind of reminds me of me, man. Like, he tries everything. Like, and he will try it and find out. I'm sure he will. But yeah, that I love that show, man. Pulse crystal growth. Let's see. It makes sense with the massive underground water reservoir 400 miles down. By the way, for those of you who don't know, there's water trapped in rock underneath the ocean. So there's like a whole more gigantic ocean under there. And think about it this way. The water goes into there trapped in like a candle wick. So if we change the gravity at all, would it change the amount of water that's on the surface of the planet? You see, changing the gravity in the center would pull more water towards the center of the planet instead of the outside. Could have had civilizations under the water as we see it now. Heck, half of the landforms around us, they have cliff faces, they have coral formations that are now rock. They have everything that you look for. If you simply just took the formation you're looking at, right? And it's a valley. Now just put water in there and draw a fish, see if it makes sense. Because although it sounds stupid, it's probably true. If we were covered in water at one time, that'd be true. Well, I wonder sometimes if that's what not those pyramids are for. And partially. I think they have more than one, reason for them being there. But I always wonder about the gravity aspect of it. And if there's giants around the time that those things were running and then they were talking about taking out the giants, that could be a clue as to what was going on with the gravity of the planet. Was the gravity of the planet lessening at the time that the flood happened? It seems right. If the water just comes rushing up from everywhere, then the planet let go of something. And if it did, then the water would rush in from the ocean and the rocks. Makes all the sense in the world. And people would be much taller by then. They'd be giants, I don't know. It's just kind of a shot in the dark, guys. You never know about that kind of stuff. I always wonder, though. Yeah, space and time. 100% tracks, yeah. I mean, it would explain all the cities that are underwater now. And if they did use that pyramid, could that energy be putting off by giving a longer lifespan? Well, that'd be interesting, wouldn't it? Something to think about. Yeah. Well, that's why they have ley lines, right? The lava, that's going to go where the magnetic field goes. If you ever take lava and, let it harden, that stuff is magnetic. You ever thought about that? And then when it goes through in the lava, is it following some kind of a field? Is it literally like the contact machine? Are they rotating in different directions, every time? And are those the ley lines? That'd be an interesting thing, wouldn't it? Yeah, more floaty water. Yeah, the ancients were wise. Let me tell you something. if you don't understand by now that they had already created a civilization that was ahead of us, but in a different way, that was more in tune with the earth and used the negative energy fields, then you should look at a lot more history, because they absolutely did. We used a lot of hot energy. We understand the whole electricity system different. They didn't have AC and DC back then, guys. They had potential. They had radiant energy. They had different things to work with. If you create a society based on those, you're in tune with the earth. If you build a society like we are, we're out of tune with the earth. We're affecting the earth in negative ways with what we're doing. And you got to start to realize that in what they're saying, right? So I don't know which one was better. They died out. So was that better? Or is it something we should look at it and say, is it better what we're doing or with the balance? See, a lot of people don't understand this. You have to have balance all the time. Balance. Okay. The hot side, the cold side have to balance. You can't create one field bigger than the other, man. They have to balance inside the earth. So a great representation, lava and water. Balance. Pretty easy to understand. High frequency in open air. Low frequency down in the earth. Balance. Pretty easy. Down in the earth, cold energy. Outside in the air that we're in hot energy. Balance. That works. I mean, just think about it. You gotta get this stuff right, guys. You gotta figure it out, man. Right on, Papa Bill. Stone cutting. Oh, by the way, let me just put this out there for you. Stone cutting, ancient stone cutting. EDM. Okay? I believe that's the acronym for it. They take electrical discharge and run it into metal to cut it. And they say the metal has to be conductive. Well, with the radiant energy, we can make the quartz conductive. Yeah, compress it, put this energy in there inside the water. We can make it conductive. You know, we can start to make some of these things happen if we start to realize that we can impart energy into the quartz. Once you get that lock on there, man, and know what it is, it's over. I mean, it really is going to work a lot better that way. And I don't know, man, maybe at that point you can use lasers in there or something to cut it away. But you just have to have the right form of energy down there in order to excite the crystal. Ley lines are considered theory. Well, not to me. But I got what's that big thing over here by me? I live in California, by the way. So right over next to me is the integratron with giant rock. And there's a ley line going right through there. Let me tell you that some of these experiments work so much better right there. The fields over there are different than they are from where I'm sitting. I'm sitting over by a fault line. Over there, energy fields are much better. So, yeah, I mean, considering California continuously earthquaking at worse and worse numbers. And then would they have a tsunami try to take out Northern California? So, yeah. But, yeah, that's one of the places I want to go and just work on stuff. Considering what energy he was using, if he took a Tesla coil and used the radiant energy from the inside of it, and you can only be in there 2 minutes at a time, it makes perfect sense. I mean, it literally makes perfect sense. If you saw what I did in my garage, it makes perfect sense. There's no getting around it. I don't know why he's doing it. Okay? Perfect sense. Death Valley, not that far. Nope. Miserable place. Drove through it on the way to Vegas. Absolutely miserable. Mystery Spot is very strange place. Yes. Guys, I also just want to see some of the tourist stuff when I go over there. It's like, I think, an hour and 45 minutes from my house, maybe an hour and 30. Not that far. Yeah. Well, I think Feels like more is going on there. Yeah, like the God said that here's your new Sodom and Gomorrah, and we're gonna take care of both of them at once. Yeah, kind of feels that way, but who knows, man? To each their own. I just know that all the phenomena going on is not a very good place to live sometimes. That, and there's fires all the time. Right on, brother. I'm glad you like the show. Appreciate it. I'll have some more, material put out there for you guys. A little more pre-done presentation coming in the next time we're gonna do. Sean's coming on Wednesday, and then we'll have to come up with a Friday show. But hopefully Thursday we'll have a special guest. So we'll see how it works out, man. For those of you who don't know, I don't have it up right now, but usually I have it up there. Every time we get members, we put up our own emojis for the show. You'll see a lot of people, like right here, it'll say Captain, and it has an emoji attached to it. When you guys see it, when I see it, it comes up, it says this. So, yeah, guys, it's so awesome with all those things. And I thank you, everybody who participates in that, man. I throw some behind-the-scenes stuff. Lately, I haven't been able to. My ankle busted. I haven't been able to get around. But, yeah, look at that. See? Joe Mushroom Conspiracy. Dude, there's a big-time mushroom conspiracy going on with Joe. That's so funny, man. We made that Star Trek episode with Joe. Oh, and Bernie. Oh, that was like the best. And Mike. Yeah, so guys, you want to get in on the fun, you can throw them up at any time, man. If somebody else is doing all the talking, trust me, I'm in the chat throwing them up myself. Yeah. Oh, Admiral Jack. Yeah, schmuck, schmuck, schmuck. That's what he says. Schmuck, not schmuck. Yeah, schmuck. Absolutely. Lots of good people. That's right. Chat's awesome, brother. Chat's awesome. Yeah, 2 females in the group, man. At least that we know of anyway. Yes. Very much thank you for watching. Schmuck, fireball, schmuck. That's right. All right. I'm going to have to get in on the action real quick. We'll do a little Joe with some holes, some fireballs, and some schmucks. Keep it top secret. Oh, man, I love it. Oh, there you go. Dude, it makes me laugh all the time. That's right, Joe, man. First met Joe when we talked about his strange rock. It had fields coming off of it, man. One of the funnest interviews ever. Right on, man. There you go. Everybody's throwing them up now, man. Ah. All right, guys. I think that's about it for the day, man. I want to thank everybody, dude, that's a member. You guys are so awesome, man. You guys make this whole show rock, bro. There you go. Oh, you gotta love it, man. Always got to have a conspiracy one in there. I love that one. Stained Rock is a classic, dude. Dude, yeah. I got to get a end of the show scroll, dude, to say thank you to everybody. And that way all you guys' chats and everything come up in there at the end. I think that would be awesome. I got to work on that one. Yeah. I like that one, man. All right, guys, I think that's enough for today. Guys, this is kind of the new format, man. This is what we're doing. Unless we have a guest on or something like that, we're going to kind of stick it to, 2 people on the show at a time. Maybe we'll just do, once we get some presenters that come in and do that, then we'll just have a big show where everybody can get in and talk and laugh and have a good time. Just, shooting the bull and having stories. But I think that's future down the road. For now, I'm going to kind of stick to the one-on-one format and just do interviews and stuff like that with people and kind of have a preset presentation when I do this stuff, man. And by the way, Brandon, I know Joe's working with you on setting it up, man. I want to do an interview with you on your stuff as well when you're ready. So that's going to be cool too. So for those of you who don't know, Brandon over here, he's got some TV that he abuses all the time. It's a plasma TV. And like me, he likes to fry things and find out. And he constantly putting high voltage into this thing. And then when he thinks he doesn't have enough, he finds a different power source to put into it. So, yeah, awesome. Yeah, right on, guys. All right. Everybody, have a great night. Thank you for watching. I really do appreciate it.